All right, welcome everybody. To this session is about building a self-healing system with event-driven automation with Gareth. We're just going to let you come in. The session won't begin for another 4 minutes officially, but in the meantime, feel free to introduce yourself in the chat and say why you're interested in this presentation, and we'll get started pretty soon. Once again, we'll probably get started in the next couple of minutes. Session hasn't officially begun yet, but while you're waiting, feel free to introduce yourself in chat, say hi, and let us know what you'd like to get out of the presentation. Welcome, Gareth. Gareth is our CEO.
Hey, sorry about that. I got lost.
No worries.
Which is hilarious in a virtual conference.
I know, right? Where's my room?
Right, exactly.
Well, we have a few people introducing themselves on chat, and we'll take a look at that.
Just going to close a bunch of stuff because Hopin is kind of heavy.
That it is.
Oops.
While we're waiting, Andrew says he's looking forward to using OpenSalt to perform tasks such as rolling out states upon initial minion join, creating profiles of states to install software, enforce how software is installed, review Windows registry entries, and run custom scripts if files or system settings have changed. Very good use case scenarios, Andrew.
It's the perfect use case for event-driven automation. That's what we like to call it.
All right, so Wesley writes that I run a distributed file system and am interested in how I can use SALT events to automate detection and fire off replacement ticket creation, for example, and other things, of failing physical components such as disks.
Okay. Alyssa, just to confirm, you can see my screen?
Yes, I can. And I think we've got a pretty good crowd here. Are you ready to get started?
I am, yes.
Okay. Well, welcome everybody to today's session about building a self-healing system with event-driven automation with Gareth Greenaway, who is a member of the core Open Salt team. So before we get started, I have just a few quick announcements, which is during the presentation, you can double-click the slides that are being shared to view them at a larger size. You probably learned that in the previous session, but it's good to say it a few times. So double-click those slides if you need to see them larger. And Gareth says that you're welcome to ask questions in the chat while he's speaking, and he'll answer them at the end of the presentation. So, all right, so I'll turn the time over to Gareth to get started. Thanks, Gareth.
Just clear my throat before we get started. All right, yeah, so as Alyssa mentioned, this is building a self-healing system with SaltStack. Just a little bit about me. My name is Gareth. As Alyssa said, I am a member of the Open team that works on Salt. My Twitter can be found on every slide in the lower right-hand corner if anyone feels like tweeting about me or about the talk during the conference. I've also included the conference hashtag, which is hashtag SaltConf20 for anyone that's tweeting. So I am a senior software engineer working on the SALT project now at VMware. I was previously part of the open team at SaltStack, and then as everyone has, I'm sure, seen, we have been acquired. So it's very exciting. I'm fortunate to be able to spend my days working on open source software. So if you ever have that opportunity, I highly recommend it. It's a lot of fun. So again, this is for anyone that had popped in after I started, this is building a self-healing system with SaltStack. So before we begin, I wanted to just do some quick introduction, some basic information about SaltStack or Salt. So some very basic background information for the benefit of anyone who's completely new to Salt. And we'll also mention some Salt terminology related to some of the concepts we're going to be talking about. So for those who are unaware, Salt is written in Python. It began as a remote execution system or a way to execute the same commands across multiple machines. So similar in nature to tools like Fabric or Func, but not over SSH. And it's encrypted using the 0MQ messaging bus, so it's very fast. And because of the way the Salt was designed, adding in additional components, which we'll look at in a little bit, such as state modules or beacons, was very easy. And it's all done using the same Salt API, which can easily be exposed for other purposes. So some of the Salt components that we're going to focus on today is the Salt event bus, which is really the heart of SaltStack and allows all of the pieces to communicate. We're also going to briefly look at Pillar, which is static secure data store, to specifically target data and information at minions or a single minion or multiple minions. We're also going to be looking at reactors, which are small Salt modules that wait for specific events and react in some manner. Example, running a specific module or state. So just again, for anyone that's new, devices that run within a Salt controlled environment are typically referred to as Salt minions. So each device that is controlled within a Salt infrastructure, Salt controlled infrastructure, is running a piece of software known as the Salt minion or Salt-minion. The Salt minion receives commands from the remote master via the Salt event bus. So the device or server in the environment that controls the Salt minions is known as the Salt master. This device runs a piece of software aptly named Salt master. The Salt master daemon sends commands to the Salt minions, again via the Salt event bus. So a typical Salt setup might include a single master controlling many minions. We can also have a setup with multiple masters controlling many minions. And we have the option to run in a masterless setup with only minions in place. So within Salt, we have the concept of targeting. And targeting is a way that one specifies which minions we want to run commands or execute a state by applied host names or system information or some sort of defined groups or a combination thereof. So here we have a couple different examples of targeting. The most common two are targeting using globbing or targeting using the minion ID. So globbing allows targeting of many minions using part of the minion ID. And we'll look at like how this can kind of be useful with some of the examples we'll look at later. So in the 3 examples we have here, which we have a targeting all minions that the state master knows about. So we're doing that with the asterisk or the glob, the wildcard. Second, we're targeting all minions whose minion ID begins with the word minion. And third, we're targeting a specific minion based on its OS. And then finally, we're using targeting compound. So in this example, we're targeting all minions whose OS grain is Debian and whose minion ID begins with web serve. So the Salt event bus, which I kind of briefly mentioned earlier, is really the heart of SaltStack and distinguishes it from Salt and others, distinguishes Salt from other projects. So the Salt master and the Salt minion each have their own event buses. And the event bus is used as used by the master to publish commands to the Salt minions, and then by the Salt minion to publish the return information for a job back to the Salt master. The Salt minion uses its own local event bus for local commands that need to interact with the running Salt minion. So here we have a diagram showing the Salt event bus. In the middle, we have the event bus with the Salt master and the Salt minions connecting into it. So we have a minion running a variety of operating systems, including Windows, Linux, AIX, and some network devices such as routers and switches. At the master level, we can see various components such as runners, reactors, engines, and the Salt API. We can also see the Salt masters providing things like Pillar, the file server, for providing state files and handling minion authentication. So we have a number of event types that that are available to us when using Salt. So we have authentication events, which are fired when a minion performs an authentication check with the master. So we also have start events, which are fired every time a minion connects to the Salt master. Key events, fired when accepting or rejecting minion keys on the Salt master. So these typically happen as a result of actions undertaken by the Salt key command. We also have job events, and a variety of events here, such as when a job is sent out to the minions from the master, when a minion returns data for a job to the master. And each time a function includes a state run when a state run completes its execution. This option is disabled by default and must be enabled with the state events option. So we also have runner events, and these are associated with Salt runners and include events for when a runner begins, returns, or whether the runner is part of the orchestration system. There are also presence events, which indicate the presence of minions connected to the Salt master. And finally, there's a variety of cloud events. So these are events that are fired when using Salt Cloud. Unlike other events that are not fired on behalf of the minion, since the minion in question may not be running yet. These are events such as when a cloud VM is in the process of being created, deployed, or destroyed. So we also have a variety of ways for listening for events on the Salt event bus. So using the event function within the state Salt runner on the Salt master, we can see all the events that are currently being sent to the event bus. And here's just a short little GIF of some events that are streaming by, would be streaming by on the Salt event bus. So here we can see like a call to pillar.items, which is returning the information. We here see like a test.ping. So we can also see these events using the Salt API using curl, providing an authentication token. We can also query the event bus using some Python code. So here's an example of an event that we would see on the event bus if we ran a job on the Salt master, targeting all minions to run the test.ping command. Events are made up of 2 main parts: the tag, which identifies the event that was fired, which we see highlighted in yellow, and the data that contains details about the event, also highlighted in yellow. So every Salt job also has a unique job ID or a JID, which is part of the tag and also included in the data in the event dictionary using the key JID. We also have IDs for the minion that match the targeting type. In this particular case, only one minion called minion2 matched the targeting criteria. Once the job is complete, another event is generated that includes the return data. The tag for this event is very similar to the original event that was generated when the job was created, but we can see that this job is a return job with the RAT included in the tag. The JID included in the tag and inside the return function is also the same JID from the previous new event. And now the ID of the minion where test.ping was run is included in the tag as well as the event data. If an additional minion had also matched the original criteria and had run test.ping, we would have had an additional event that was returned from the same JID, but with a different minion ID in both the tag and the event data. As mentioned before, we also have authentication events. So here's an example of an event when a minion first connects to the saltmaster, but has yet to accept its key, have its key signed by the master. We can see this indicated by the key ACT and the value of penned. When dealing with salt events, it can be useful to be able to send events to the saltmaster bus, salt event bus. We also have a couple different options for doing that. We can send an event to the minion's local event bus from the minion itself, using the salt call command on the minion and the event module with the fire command. We can pass the data that we want to send inside a dictionary and including a tag identifying the event. We can also send events from the minion to the event bus on the master, again using the salt call command on the minion, but this time calling the send command in the event modules. We include a tag, in this case, mytag success, and the data that we want to send in the dictionary. We can also send a command, send an event on the event bus from Python, for example, in a custom event module. Here we're calling the same event.send function as before, but we're using the dunder salt dictionary to make the call. If we're watching the event bus on the saltmaster using one of the techniques we looked at earlier, once the saltmaster received the event, we should see something like the following. We see the message containing the tag that we specified and the data dictionary containing a message item from within our message of it works. So seeing all the events show up in the event bus, including our custom events, it's great, but we want to be able to do something useful with them. So enter the Salt Reactor System. Salt Reactor System gives the Salt Reactor System gives Salt the ability to trigger events in response to an event. Is a simple interface for watching Salt's event bus for event tags that match a given pattern and then running one or more commands in response. The system binds Reactor SLS files, similar to Salt state files, to event tags on the master. These Reactor files then define the reactions that should happen when the saltmaster sees an event with a particular tag. And so we have a couple different reactions that we can set up to trigger based on the events that are coming into the Salt event bus. Local reactions are reactions that can run any of the available remote execution functions on a targeted minion or minions. Runner reactions are reactions that execute a runner function directly on the master. Wheel reactions are reactions that execute a wheel function on the master. For example, an example of this type of reaction might be having minion keys being removed once an AWS instance has been removed. And we also have call reactions, which are reactions that run remote execution functions on a masterless minion. So reactors are set up on the saltmaster in the master configuration file or in a separate file in etc salt master.d. All the events that we want to have reactors set up for are included in a list under the reactor heading. We can include events with wildcards, such as the two here that watch Salt minion wildcard start and Salt cloud wildcard destroy events. Each event then has another list of all the Reactor SLS files that should be running when the saltmaster sees an event that matches this criteria. So here we have a very simple Reactor file. The syntax should look similar to that of a state file. Reactor SLS files only have access to a minimum Jinja context. Gradients and pillar are not available. The Salt object is available for calling remote execution or runner functions, but it should be used sparingly and only for quick tasks. In addition to the Salt object, the following variables are also available in the Jinja context. So we have tag, and that is the tag from the event that was triggered during execution of the Reactor SLS file. And we also have data, and that contains the event data dictionary. The data dict will contain an ID containing the minion ID. if the event was fired from a minion, and a data key containing the data passed to the event. One possible use for the reactors would be to tie them into some sort of monitoring system, such as Nagios, Sensu, or Prometheus. We can set up a simple reactor file that looks like a simple reactor that looks for an event with a tag of monitor/restart/service. In the event that this tag ends up on our Salt event bus, we then execute the reactor SLS file restart_service, which is found on our Salt master by default in SRV Salt Reactor. In the event that the Apache web server service stops on any of our web servers with the host name, on our web server with the host name aptly named web server, we can have our monitoring system fire an event onto the Salt event bus by running the following command from that minion or connecting to the Salt master via the Salt API. We're including the appropriate tag monitor/restart/service, which tells the Salt master that we want to trigger reactions associated with restarting a service. We keep the reactor SLS files as generic as possible by passing the information about the minion, where this problem has happened, and the name of the service that is having the problem as items in our data dictionary. Watching our event bus, when this event fires, we'll see an event like this. We'll see that the event has the correct tag that will trigger the service restarting reactions. We can also see that items that we included in the command for the ID of our server and this service that has stopped are now included in the data for this event, but that the ID where this event originated is different than and is likely our monitoring server. Our restart_service SLS file might look something like this. Here we're using some Jinja templating to pull out the service and ID from the data variable in our event. We're using some local reactor calls to the start function in the service module. We're targeting the minion that was included in the data, and we're passing the name of the service that we want to restart. We can expand on our previous example. Here we are again calling a local reactor, but this time we're calling the apply function to the state module. We're targeting the minion ID that is included in the event data. Here we're applying a state.apply call on a state file on our Salt master called restart_service. And we're passing the name of the server and the service to the state file using pillar values. Inside that state, we can then pull those pillar values, out into local variables using Jinja. Then calling the running function in the service state module, we can ensure that the service is running. Additionally, we can post a message into Slack, letting whoever happens to be on call know that the particular service was restarted. We can also do some basic monitoring and repair directly within Salt. So enter beacons. Beacons let you use the Salt event bus to monitor non-Salt processes. The beacon system allows the minion to hook into a variety of processes and systems, and then periodically monitor these processes and systems for changes. When changes occur in a monitored process or system, an event is sent on the Salt event bus that can be used to trigger a reactor. Salt beacons can currently monitor and send events for many system activities, including file system changes, system load, service restarts, shell activities such as successful and failed logins, network and disk usage, and then in the recent Neon release, a beacon to monitor the expiration dates of SSL certificates. So on our Salt minions, we can configure a beacon by adding the configuration to the Salt minion configuration file or to a separate file under etc salt minion.d. All beacons need to be under the beacons header. In this example, we're setting up the service beacon to monitor the Apache 2 service. For this beacon, we're including the on change only and unclean shutdown options. On change only will ensure that the beacon only fires an event when the service status changes. And the unclean shutdown option tells the beacon to look for a particular file that would have otherwise been cleaned up if the service was restarted cleanly. For example, a PID file that was written out by the service management system. Once your beacon has been set up, we might see an event such as this on the event bus if the Apache 2 service was uncleanly stopped on our minion. We have the service name, the minion ID, and the status of the service in question, in this case Apache 2. Once Apache is running again, we'll see the status change. We'll receive another event very similar to this one, except the status of running will be true. So we updated our Reactor setup to look for the new event that the beacon will be sending. Our Reactor file is very similar to the previous example, with one additional pillar value being passed to the state file. We now include the status of the service. We'll see why once we look at our updated state file. Our state file should look very similar to the previous example. We've included some additional Jinja to pull the value of service running from pillar. We then use that value to determine if we should run the rest of the state file using the Jinja if block. If the value of service running is false, then we want to run the service.running function and send along a message to Slack. If that value is true, then the service is already running and we'll skip this code block. As our reactors become more and more complicated and our state files, potentially adding conditionals such as the if-else statement that we added here, we have the option to rewrite those reactor files in pure Python. Here we have the equivalent reactor file, but in Python. We can also do the same thing for our state file that is called from a reactor. This example has the conditional, which is more cleanly done in Python than in YAML. And the final thing I wanted to talk about today was regarding salt events and having events on the event bus is engines. So salt engines are long-running external processes that leverage salt. They run in a separate process that's monitored by salt, and if the salt engine stops, it's restarted automatically. Engines can run on either the salt master or the salt minions. So salt engines can connect to an external system or an external application to pull information in and place it on the event bus. Some examples of currently available engines that are included with salt include engines to monitor events from Docker, libvirt, and Amazon's SQS servers. Additionally, an engine to monitor Slack, such as acting like a Slack chatbot and feeding commands from Slack to Salt. On our Salt minion or our Salt master, we set up engines. This is done in the Salt minion configuration or a separate file under etc minion.d or master.d, depending on where you're configuring the engines. And all engines need to be under the engines header. In this particular case, we're setting up the Docker beacon to monitor the Docker events on a particular minion. For this engine, we're also filtering the events that we receive from Docker. We only want to see events from when the container is started, stopped, or when the container dies. Once our engine has been set up, we might see an event such as this on our event bus when the Docker container is started, and a similar one when the container is stopped. Once these events are available on the Salt event bus, we can then use reactors on these events when scaling up application deployments when necessary, adding the containers into a load balancer, for example, when the container is available, or when scaling down during low peak traffic, removing the containers when they're destroyed. Some other potential areas where we can take advantage of beacons, engines, and reactors to provide self-healing infrastructure. So using the btemp and wtemp beacons, we could monitor system logins and react when certain failed logins have occurred. We could use the iNotify beacon and look for file changes and ensure the files in question are in the correct state. We could use the disk usage beacon, monitor disk space on the servers, and clean up or archive when space is getting low. This could be very, very useful when dealing with logs. And finally, we could have a custom beacon or engine that monitors firewall rules, such as IP tables rules, to ensure that rules haven't been removed or any unnecessary rules haven't been added. So in review, we looked at the various ways in which event types, the various event types are available with Salt. We looked at the ways we can listen for events using the Salt command line tools, Salt API, or some Python code. We looked at what a typical Salt event looks like and discussed its various components. We also looked at ways we can send events to the local Salt minion, as well as the firing event up to the Salt master, using both command line tools and some Python code. We looked at the Salt Reactor System and how we can have Salt run execution modules and state modules in reaction to certain events. We also looked at ways we can utilize Salt events on the Reactor System when monitoring solutions to restart services. And then finally, we looked at how beacons and engines can be used to have Salt do some basic monitoring repair work. So I hope that this has piqued people's interest in using Salt reactors and engines and events. And so we have, I believe, some time available for questions if anyone has any. And I want to thank you all for attending SaltConf. As weird as it is being virtual, it's great to see that our attendance is like super high and that people are attending the talk. So hopefully it's beneficial. And then I will take questions for as much time as we have left.
All right, so let me tell you some of the questions that were asked during your presentation. We'll start with that. And then while we're going through those questions, feel free to put some more in the chat. And if you're feeling brave, I might even let you come on the stage to ask your questions. And the way you come on the stage to ask a question is to click the share audio and video button on your screen. So feel free to do that if you are feeling brave. So let's go back to some of the questions we had during your session. Christopher Gray asks, does the event bus require a minion to send the event, or can non-minions also send events? And the use case that he has in mind is a load balancer that notices a machine is getting overloaded and notifies Salt for remediation.
That's a really good question. So in that case, you would not require a minion to send an event. You could tie into the Salt API to send an event. So if you're able to somehow, from your load balancer or from some other system, send an event to the Saltmaster, that would be one way to go. I will also point out that a lot of one of the efforts that we've done over the last few months, not like we as a team, not me personally, is getting what we're calling native minions on a lot of network devices. So depending on the device that you're using, it may be possible to get an actual Salt minion on that device, and that might be one option as well to look at for sending events.
Very good. All right, we have another question from Sri. He says, can minions send events even if there's any Can a minion send an event if there's any state changes in the server? My apologies.
Can minions send an event if there's any state change in the server? So anytime a state runs, it does generate an event, and that shows as an event, as a change event. And so you could have a reactor that is running based on the event. I think I answered your question, Sri. Is that accurate?
We'll wait to see if he responds in the chat. While we're waiting for that,
Yeah.
Oh, he said yes, by the way. Very good. Okay, so
Yes.
We have another question from Andrew. How do I set beacons to look for changes to grain values?
That is a good question. I don't believe we have a beacon right now that looks at grain values, but one option you could do is have, because grains are usually, at least custom grains are stored on the minion itself. So you could have, and they're typically stored in a file within the minion configuration. So you could have an iNotify beacon running on the minion that is watching that file for any changes, and then generating an event. That's a really good question, though. I could see some potential use cases there. Yeah, I'll have to look into that, because that's something I don't think anyone has thought of, like how to monitor actual running beacons. Yeah, Connor pointed out that they're typically stored in Etsy Salt grains or the Etsy Salt minion configuration file, or under minion.d.
Very good. So Tom asks, how can we use these with a minionless install? I'm new, but I think it's called Salt SSH. We have a set of devices that run MIPS or MIPS, and I don't believe we can install minions on them, but we want to be able to monitor statuses from those devices.
Right. So we have Salt SSH, But because of the way the original SaltStack project worked, you don't get access to a lot of minion, a lot of the niceties of regular full salt SSH minions. But one of the projects that has been temporarily put on hold, and hopefully gets picked up again now that we're kind of, the open team is kind of getting back to more development, is a project called Heist. And so what Heist is like a new generation of Salt SSH. And so it gives you, the way it works, you actually end up with an actual running minion on your device. And so it's communicating via SSH, but it's an actual minion. And because it's an actual minion, you get access to the whole event bus and beacons and reactors and all that good stuff. So that might be something to look at. You could also look at running, if you wanted to run like a proxy minion on those devices. So proxy minions allow you to point, yes, thank you, Megan. Megan gave the link to Heist on GitLab. So proxy minions allow you to run against devices that can't run like a regular full-blown minion, depending on like lack of resources, memory, CPU, or just whatever. Like they just don't have the capability of running software. So they also get access to the event bus. So that might be something to look at too. We have an SSH proxy minion that you can use to target devices.
And did you see the comment from Jerry that says that Heist would require Python? To the best of his knowledge, MIPS doesn't have a working version of Python.
Right. So yeah, Megan actually answered the question. So the way that we're bundling Heist, it's in the single binary. So we actually package a version of, this is using the new project called Tiamat. So we actually bundle everything that you need into a single binary and then send it over via SSH, and then it deploys and runs. So it doesn't matter what version of Python is available on that. He mentioned, or Jerry, I don't remember if it was Jerry that asked the original question, but he mentioned that it's MIPS. So it would need to be built for MIPS, which I don't think we do currently. But I don't imagine that would be too famous last words, I'm sure. Easy to get going.
Well, very good. These have been some good questions. Keep coming in the chat. In the meantime, I'll ask a couple of questions. Have there been any cool use case scenarios for reactor systems or event-driven automation that you can think of in past memory that you were like, okay, yeah, that's an interesting application of that?
Yes. So I remember talking to someone years ago that was using Salt. He was managing his company was managed casinos, like slot machines in casinos. And so he wanted to be able to see what, basically like know when, like if something had happened, like if there was like a security breach or something like within like a slot machine, someone had tried to do something. And so he had a salt minion running on the casino, the slot machine itself, because they're basically just like computers. They were embedded Windows machines, which was kind of scary for me, thinking of like that they're slot machines and they're handling money. But yeah, he was using Salt to manage those and had some like event-driven orchestration behind them.
I'll mention one that I've heard of from Dave Boucher, who's on our sales enablement team. He had a factory that they had a system where they had a machine that would have a regular time that it would go down, like it would just kind of periodically go down for a period of time, and it would just halt their production line in this warehouse. And so they were able to, I think the downtime was on average about like an hour, which is a big disruption in a factory setting. So when it would go down, they would have to like go get the guy to fix it, and then he would come and fix it by hand. By enabling the SALT event system, when the machine would go down, it would kick off a series of events that would help it heal itself and get the machine itself up and running, because it was the same process every time, so it could be automated. And so the downtime went from an hour to 2 hours to 15 minutes. And so it saved them a ton of money in production costs. So.
Yeah, I mean, those kind of examples are they really show I mean, that's, I think, probably a pretty niche example of someone doing it. Probably most people are using Salt. They're not doing that. But if you think about the applications where you could take that basic concept and apply it to kind of a general infrastructure, like you could have something where, like, I mean, the super basic example that I used with like a service goes down, like you could have it restart, and if something like that happens in the middle of the night, you don't necessarily need to have someone page, have someone log in. Like, we'll first wake up, like log in, take a look. Oh, why is this like happening? And so you're able to kind of keep things going. I mean, in the case of the factory, I'm sure they have all sorts of monitoring in place, but it doesn't necessarily need someone to get in there manually and do it to like keep things going. So, yeah.
Plus, keep your employees happy, not having to wake up in the middle of the night to go fix a machine.
Exactly.
Right. So everybody wins. All right. I don't see any more questions, but let's see. Any other use cases you can think of for event-driven automation that come to mind? Anybody in the chat too is welcome to chime in with some interesting scenarios.
Yeah, please. Always love hearing like how people are using the software. I mean, one of the things that like Tom mentioned in his keynotes that has always been like in the 3 years that I had worked for SaltStack before the acquisition, and the 3 years that I had been contributing to the project. One of the scariest things, and one of the combination like awesome things and scary things that I've always found is talking to people about how they're using the software that you've written. Because like on the one hand, you're thinking like, oh wow, that's awesome, like you're using the software I wrote. But on the other hand, you're thinking like, oh crap, you're using the software I wrote. Like, so it's always fun just to hear like how people are using the tools. One of the most interesting things is like how like the different use cases that people come up with it, that you just don't even think like, oh wow, I hadn't thought about like someone using that.
So did you see Andrew? He's saying one thing he wants to do is check if users uninstall the software and then use Salt to auto install it again, and additionally to check for new software that shouldn't be there and then to uninstall it.
Yeah, so depending on the operating system that you're using, we have a beacon that monitors the package system. So I'm not sure if we have it working on, or if anyone's used it on like a Windows system. But if you're using like a Debian-based or Red Hat CentOS-based system, it can monitor packages that are installed or not installed, and just periodically check and see like, hey, is this installed? No, it's not. Okay, go ahead and install it. Or is this installed? Yes, it is. Go ahead and remove it. And also look for if there's updates to that software. So that may be something to look at. I do not know if it's, so it uses the underlying.
Will you just read the full question out loud? So
oh, sorry. Yeah. Sorry.
No, you're fine.
I always forget that part in conferences.
No, you're fine. Go ahead.
So Andrew was asking, do you know if it will be available in Windows soon? So the beacon in question uses the underlying package module, which is agnostic across all the different packaging systems that we're using. So if there is a package module that is using that is supported on Windows for your particular use case, then the beacon the package beacon module should work. I don't actively use or support Windows as a user, so I don't have a experience using it. So I don't want to speak authoritatively that it does work, but in theory it should.
So Ellen had a question a little bit back. Could we use event-driven automation to spin up emergency proxies for a device if the regular minion becomes unresponsive?
Yeah, I mean that's one of the. I mean, just going back to Heist for a moment, that was one of the use cases of SaltStack in general. Was again a case where I mean, just like initially getting a salt minion onto a machine where you don't have access to, or like a whole host of machines that you don't have access to. You don't want to necessarily log in to each and every one to install the software. You could set up, like you use either a proxy minion or set up like SaltStack or Heist or equivalent to get into the host to install a salt minion. So I could definitely see how like a use case would be if a salt minion becomes unresponsive, you could use a backup proxy or a backup Heist minion ID to get into the machine. I hesitate to use the word backdoor because that has negative connotations, but an emergency key, if you will.
Awesome. We have a comment from Tom where he says, we have a set of Linux-based routers that struggle to keep VPN connectivity up all the time. The routing is dynamic and self-healing, but we're looking to use SALT events to monitor those VPN tunnels and bring them back up and heal the broken legs of the network.
Okay, yeah, that sounds like an interesting use case. Probably... I think there's if I remember right, the status beacon does some network connectivity, or there's yeah, I'm blanking on the specific beacon that could use if there's an existing one, or it's a perfect use case for a custom one. Beacons are actually really easy to write, so I could see like a basic beacon there, just like monitoring whether like you have connectivity back to the master, or even just like not even that, just like watching for like presence events for a minion. Like if you have a minion on the other side of the VPN and you're monitoring presence events, and all of a sudden the minion goes away, like you have some idea, like okay, it's probably that the VPN went down, so go ahead and restart it. Did that answer your question, Tom?
Hopefully.
Hopefully.
All right.
Yeah.
Well, so we have another question from Sridhar. Does event-driven automation / auto remediation always require a master, or can we also set up through masterless architecture?
So you can do events through masterless with a masterless setup. You just don't get as many access to as many things as possible. So I haven't used it myself, but I believe that the reactors would be on the minion. I don't know if anyone else in the chat has experience with that, but I believe the reactors would be, as I said, on the minion.
Sounds like it's possible if
Yeah,
someone wants to chime in. Yeah.
Yeah, totally. Most of my experience with them is in like the traditional kind of master minion setup.
Very good. Any other questions from people in attendance about event-driven automation? You've got Gareth, the expert here. It's nice to be able to chat to somebody directly.
Yeah, and I'm available. Oh, I'm home all day, but I'm available in virtually all day to if anyone wants to hit me up with questions.
If while we're waiting for more people to ask questions, what are the best ways to? We make ourselves pretty available on the open team. We like to be available to the community. What are ways that you? What are the best ways that community members can interact with you?
Probably on our community Slack is the best way. I'm pretty easy to find. My Slack name is just my first name, last name. So yeah, I've answered questions on Twitter as well. Again, simple first name, last name. People have tagged me in like issues on GitHub. So again, simple first name, last name. So yeah, I'm pretty accessible digitally.
Nice.
We actually got another question from Alan. What are the alternatives to this automation and why might they be inferior? That's a good question. I don't know what someone else would do. Like I haven't had to think about that for a few years. So yeah, I mean, I guess like the alternative to like one alternative is like doing all this stuff yourself and like manually, not using automation. And that's inferior because you're doing it manually. I mean, back in the day, like people used to do, like if you had like your monitoring solution, you could have your monitoring host like manually run a script similar to like the example I gave of like Nagios calling, like making a call to the API server, running a salt call command. You can have Nagios or Zabbix or Prometheus or Sensu or any of the other monitoring solutions run a script or manually SSH into a machine and like do it. And so like a kind of sort of pseudo automation setup. And I would say like, I mean, while those work, I don't want to like disparage another product or project's approach, but there's a lot of moving pieces there, especially when you're doing something like SSH. SSH is, while it's a reliable protocol and like a reliable tool that's like years and years of development, it's still a moving piece. So and it's serially in most cases. So whereas like event-driven automation, the way that we do it in Salt, it's all it can all be done in parallel. So like if you had like a host of 10 web servers that you were monitoring and all 10 of them went down, you're not going serially one by one to run those events to get them back up and running. You can blast out that like all 10 events onto the event bus and have them all up and running in a relatively smaller time frame.
Automate the boring stuff, right?
So Tim asks, yeah, exactly. No, I mean that's the whole reason for like why like so many of us like have gotten into like automation software. Why it's so exciting is like you automate the stuff that you don't want to do like on a daily basis. Like, yeah, no, I was just gonna say Tim Morley asked the question. So I'm thinking we could utilize this setup and get rid of Zabbix. So I don't want to make the claim. Like I usually preface the comments when I mention that Salt can do like basic monitoring. I don't want to suggest that Salt is a monitoring tool. It can do basic monitoring, but tools like Zabbix, Prometheus, Sensu, Nagios, their specific jobs, their specific reason for being developed is monitoring. So while you can do some basic monitoring with Salt, I wouldn't recommend, like if you have a tool that does it, I wouldn't recommend like ripping it out and replacing it with Salt. I think Salt can be used in conjunction with those tools to get some benefit from. But yeah, I don't want you to go to my boss and say like, hey, Gareth said like we had a huge outage because Gareth said like we should use Salt for our monitoring tool and it didn't work. So
replace piece by piece or something like that, right? So
yeah, totally.
Alan had another question. If separate teams have to interact with the same automation system but for different reasons, what are some team best practices so that they don't step on each other's toes?
So keeping everything in Git. I would say is like a best practice. So one of the things we have in Salt, that's actually, I see Eric Johnson, former SaltStack employee, big Salt contributor. I did a lot of work with is like things like GitFS, which allows you to store your salt states and all your salt data in GitFS, in Git, and then have Salt periodically pull it down. So things like that, breaking out your components into different projects would be like a good best practice. That way, like one specific team is responsible for one specific area of the automation. Yeah, things like that would be some of my recommendations. And I'm sure like everyone has their kind of go-to ways of doing things that that work best for them.
All right, we had some good comments in that last session, or in that last little bit. So Alan asks again, what is the most production-friendly way to disable event automation temporarily for manual adjustments that Salt is supposed to be auto-managing? He's run into operator versus automation problems before.
So yeah, you can for a lot of these, you can set you can turn off certain events within the master or the minion. So that's one approach. A lot of the beacons have kind of options to disable them. So within Salt on the minion, there's actually a Salt module that you can use to interact with beacons, and so you can disable certain beacons from running for certain times. So that would be one approach. You can tie that into like the scheduler if you want, like to say like, okay, at this time turn it off, this time turn it back on again. So that would be a couple different approaches. Did that answer your question, Alan?
I think so. All right, so Daniel asks, we want to put Salt Minion on EC2 instances in an auto scale group. We'll want to remove Salt Minion keys to terminated minions from the Salt master so we don't have a graveyard full of dead keys. Someone suggested we could do this with reactors and beacons. Can you talk through what this might look like?
Sure. And I'll also point out there's also there's a Salt engine called the stale keys engine, which will, when enabled, will go periodically clean out any keys that it hasn't seen like a presence event from in a while. But back to the question of using like beacons or reactors. So if you're using something like Salt Cloud, and I think ITOms supports this as well, or Item Cloud. So they generate events when an instance is created and destroyed. So one of the events that you could set up a reactor for would be watching when an AWS instance is destroyed, and then go ahead and run a runner reactor that would run I'm blanking on the runner, what it would be specifically, but to go ahead and delete the key for that particular minion from the master. That's actually a really common use case of reactors when you're dealing with cloud instances, is because you don't want to have all those keys left over, because then when you go to target, like if you go to target all your minions, like it's going to attempt to target minions that no longer exist. So yeah.
So we've got 1 minute left. Probably time for one more question. Does anybody have a burning question you want to ask? Alan asks me if we have a docs page for the engine. I don't know. I will look into that and make sure it's a good one. Because I've had a lot of that come up today already, like with the Slack engine and things like that. People are interested. So I will look into that, make sure we have a good docs page. I'm the technical writer in case you're wondering, people.
Yeah.
Oh, there we go. Megan put one in.
So that's the engine that I mentioned, the stale key engine. And then there's all the other, there you go. That was the question Alan had.
Okay, well, we have reached the end of our session. That was so good, Gareth. Thank you so much for giving us like, for me, it was just nice to have like a good rundown of the basics of salt and how everything interacts with each other. And I think everybody's walked away with some really good examples of how to use beacons and reactors in their systems. So thank you so much for presenting today. And thanks to everybody for coming.
Yes, and thank you to everyone that
Yeah.
attended. This was great, and hopefully the next SaltConf we're able to actually hang out in person.
Yes, I
So
agree. Okay, thanks everybody. See you later.
thank you.